Hi, everyone. Welcome to the Computer Perception Workshop, which is about the design and evaluation of general perception models. And this is jointly organized by Viorica, me, Dima, and Andrew Sisserman. We're interested in these very general perception models that, for example, a bee has. So a bee needs perception to be able to tell where the flowers are, to go get some pollen, and to navigate back to its nest. It also needs perception to fend off threats like wasps. So very different goals in those two cases. Or, for example, a dog needs a very good perception that can tell him exactly how scenes are changing, so it can jump in the right moment to catch a flying ball, for example. And yeah, another aspect of very general perception is that animals will have very different bodies with very different sensors. Some may have eyes, some may have noses, and very different bodies. And an important part of perception is also knowing where your body is, and if that body varies a lot, then across different animals, perception needs to adapt as well. And we have the same issues in our fields, in non-biological systems. We have cars with sensors, we have phones with very different sensors, we have drones, and so on and so forth. So we want to have a very general perception technology that can quickly adapt to various body types as well. And of course, one of the most important sensors and the most important aspects of perception is vision. So that's our dominant sensing modality. And initially in the field, people are very ambitious and try to solve a large chunk of vision from the start. So there's this almost legendary summer vision project from MIT that basically wanted to build this very general segmentation system that would detect objects, recognize them, recognize also background, and they have a third category called chaos, which I assume it's things like reflections and very tricky things like that. And yeah, so that was the initial plan, but of course it was very difficult for many reasons. So people did what they usually do. They broke the problem into many different sub-problems and eventually managed to make progress on many of these. But at the same time, there's this very large fragmentation of vision into all these problems, which is a bit of a departure from what ideally we want, of having these very flexible perception systems. And a somewhat complex metaphor maybe that yeah, we've built all these devices like a map to know where we are, a typewriter to be able to type, a video game to have fun, or a calculator to make compute logarithms and all that. But maybe the more valuable thing is to build a computer that can do all of these things and many more in an integrated fashion. So this analogy between developing many different vision models for very different tasks versus like a more general one that can deal with many different things. So, of course, people have also thought about this in the community, and there's a growing interest in consolidating back on the model side. For example, combining audio plus video, or image plus language, or image plus LiDAR. But some of these early attempts are somewhat complex. So you can see that there's many different components, and they still don't support a large variety of tasks. So at DeepMind, we've been interested also in this problem, and we try to maybe too extremely simplify it and build a model that we call the perceiver that just takes in arbitrary inputs and just produces arbitrary outputs. And the idea is to have like an attention transformer type model that receives just an array with, it can be vision, audio, or anything else. And then it receives also like a query array that specifies a particular task, and then the model does some cross attention to some latent space, and then produces all the outputs you need for every particular task. All good still with the slides? Yep. Okay. And yeah, there are also other approaches. So for example, generative models. There's this famous system called Pix2Sec that just takes in images and then produces arbitrary outputs as text. This is quite flexible, can do object detection, segmentation, and other tasks. And we also have an internal approach called Transframer that just models all tasks as generating pixels. So you would have like object detection as generating images with some boxes rendered into it. You could generate a video or depth maps or semantic segmentation. It's also a very flexible approach. And yeah, another strand of very general models include text to image and text models like Flamingo or Bait3, which can, given images or videos, can basically solve any task that has text as output. And yeah, so this is one aspect, how to go about building models that are very general for perception. But then the community, in order to make progress, needs to be able to evaluate them. And you know, still 10 years later, and we have Olga here today that built ImageNet. A large fraction of the community is evaluating just on ImageNet or on other classification tasks, say in video, like kinetics, which are great and led to lots of progress, but give us just that little single number to tell us how good the model is. And you know, that's not very informative. And you know, perception is not just classification as well. So we want to measure many other different things, and know in you know, along multiple axes what's wrong with or right with our models. Then, so on that note, we've been for the past couple of years building a benchmark that we think is more general than existing ones, called the perception test. And this workshop will also serve to publicize and give details into that a little bit. So this is a blog post we had at the DeepMind website just like last week or a couple of weeks ago. And yeah, so this benchmark was built by this large and you know, very good team from DeepMind. And yeah, in this workshop, we'll on one hand publicize this perception test, but we'll also discuss perception more broadly. And we have an excellent lineup of speakers that are great just for that. We handpicked them, and fortunate that they accepted to come. And this is the agenda. So opening notes, that's what I just did. Now afterwards we'll have almost an hour of just going about the perception test and the philosophy behind it, with Viorica and Dima. So Dima is also part-time at DeepMind, also at Bristol. So that's going to be the first part. Then we'll have a lunch break because this is like we're using Tel Aviv time, and it's already late there. Then we'll have Olga speaking. Then we'll go into more details on perception test and explain all the annotations we have. Then a coffee break. Then a few keynotes. Another coffee break. More keynotes, and then we will go into a hopefully very interesting panel discussion before we end. Yeah, with this, I'll pass on to Viorica and then Dima, who will tell us about the perception test.